Now the second point is to measure the osmotic pressure. The Barkely-Hertly method is the best method, because in that method the pressure is applied from the external, so that because of that the chances to rupture the SPM is less, right? So the best method to measure the osmotic pressure is Barkely-Hertly method, because the following reasons I am going to write here A, B, C, right? So the A, because this method is more convenient, right? So this method is most convenient. Now the next is B. In this osmotic pressure is measured accurately. Right? And C is, in this the external pressure is applied as osmotic pressure, so less chances to rupture the SPM, right? So these are the positives of this method, Barkely-Hertly method. This is the best method to measure the osmotic pressure. Now the next is, I am going to draw here the diagram of this method. So this method diagram is, this is the so here is the barometer, this is the barometer, right? And here is the this is the solution, and this is the solvent, and these two separated through the SPM. In between it is the SPM, right? So here external pressure is used to stop the osmosis, and easily osmotic pressure can be measured, right? Now the next point is, so one more method is there to measure the osmotic pressure, that is through the Thistle funnel. So I am going to make the diagram here. The Thistle funnel diagram is the extra of this. This is not related to the Thistle funnel diagram. It is the Thistle funnel diagram, right? It is, suppose here is a and here is the funnel, right? And here is the water. And the SPM is there. this is the SPM over the Thistle funnel. So this is SPM, this is Thistle funnel, and this is the solvent, right? And here suppose the solution height is H1 and after the osmosis solution height will be H2, right? Suppose there is a solvent and the solution, so solution here, right? Here is the solution. Suppose here the height before osmosis is H1 and after osmosis it is H2. So this will be the delta H and the pressure can be measured with the help of this delta H. Pressure is equal to H dG, that is delta H, right? And this pressure will be the osmotic pressure. Osmotic pressure, right? So this is a Thistle funnel diagram. So this is all about the osmotic pressure. Now the reverse osmosis. So reverse osmosis is actually the flow of solvent particles reverse in the direction as in osmosis. That means when the external pressure is applied on the solution side more than the osmotic pressure, then the flow of solvent particles takes place from the solution side to the solvent side. So it is in the opposite direction as in the osmosis. That's why it is called the reverse osmosis. So let's start. If the pressure greater than the osmotic pressure is applied on the solution side, then in osmosis, then the movement of migration of solvent particles takes place from solution to solvent. This phenomenon is called as reverse osmosis. Why reverse osmosis? Because the migration of solvent particles is in the reverse direction as in the osmosis. So migration or movement, or you may say the migration of solvent particles takes place from solution to solvent side, right? That is for the reverse osmosis, or in short it is called as RO, right? So this reverse osmosis occurs when the external pressure is applied on the solution side more than the osmotic pressure. So here E external is greater than the osmotic pressure, right? Or it is on the solution side, right? So this is the reverse osmosis.